Hey everyone, we're gonna do topic 4. Foz is here to help, right, Fozzie? Fozzie says yes. He's very excited for topic 4. All right, so let's go ahead and dive in. I'm gonna have you guys turn to page 96 in your practice book. We're gonna do section 6, topic 4. Right? He's very excited. And he is left. So let me go get our study buddy and let's dive into topic 4. Our favorite study buddy's back. He's over here. There he is. All right. Hey, Fozzie. So Jessica is eating a bag of sour Skittles. Seriously, a bag of sour Skittles. And her friend asks her to share, and Jessica throws over an extra bag. Her friend does not catch the bag, and it hits the ground. The distance from the ground for the bag of candies is modeled by this function, h of t equals negative 16t squared plus 32t plus 4, where h of t is the height, or distance from the ground in feet, of the candies, and t is the number of seconds the candies are in the air. Describe in a paragraph what the graph of the scenario would look like. All right, so let's ignore the sour Skittles stuff right now. I know, we're going to ignore the sour Skittles stuff first, though. And we're going to focus on the formula. H of t equals negative 16t squared plus 32t plus 4. So we're going to slowly figure out little things about this, and that's kind of what we're doing in this section, right? This first one's a little trickier, and I'm going to do some of it for you. The easiest thing to look at, though, is what our y-intercept would be. So let's look at what we know. So our y-intercept, if you remember, y-intercept is when x is 0. So, oops, okay. So, I know I gave it away. If we plugged in 0 for t, 0 squared, and then 0 times 32, we get 0, 0, and we're left with just the plus 4. So our main height would be 4. And I put the initial height was 4 because we're starting off with where she threw it from. Nothing in the negatives matters. We're not, because it didn't actually travel the way it did from the negatives. It started from her hand for when she threw it. So the next thing we can tell is how and when it hit the ground. And that's by finding our zeros. So you've all done it. You love it. You're going to plug in and do your quadratic equation to get your zeros. Right, Fozzie? So what's our quadratic equation? Negative b plus or minus square root plus or minus square root. B squared minus 4ac, b squared minus 4ac over 2a over 2a, right? Right, Fozzie? All right. So, if you did all that properly, you should get that your positive 0 is 2.1. So, I'm talking about my positive 0 because remember, nothing in the negatives matters because she didn't actually throw it till we get to our positive axis in this case. You are so cute. You're such a good little videographer. We're mostly concerned about our positive 0. However, using our zeros, we can actually find what our vertex is, which would be our maximum height in this case, right, Fozzie? And I'm going to go over that more in the next couple questions, so I'm going to go ahead and give it to you. That our maximum height is 20 feet. 20 feet. Do you know what that means? That means that the bag of sour Skittles is thrown from an initial height of 4 feet. After 1 second, the bag reaches its maximum height of 20 feet. I know, and the bag of candy hits the ground at approximately 2.1 seconds after being thrown. I know! Isn't that so cool? Yeah? Okay. The next one, it'll make more sense on how we're able to find that out. So bear with us. All right, so now we're given g of x equals -2 times x minus 1 times x plus 5. Yeah. Seriously. Seriously. All right, so you could multiply that out and do certain stuff similar, but I actually think it's easier to solve when it's this way. And you're going to see later on in our practice book, we're going to be turning certain equations to look more like this because it's so much easier to get our key features, so to speak. So let's look at this. I can immediately tell what my zeros would be. Do you know how I know that, Fozzie? Because if x minus 1 becomes 0, everything multiplied by that would be 0, and same with x plus 5. So if I do x minus 1 equals 0, and x plus 5 equals 0, I'm just going to do Fozzie Cam for most of this, then you'll see that if x was 1, because 1 minus 1 equals 0, or if x was -5, then you get 0 for both of these. Do you see how I got that? Do you see how I got that? Yeah? All right. So now we can do two different things. We can find our y-intercept, which is what I believe I did first, and we can do that because we know our y-intercept is when x is 0. So when x is 0, which we can plug in for, we get 0 minus 1 and 0 plus 5. So we get -2 times -1 times 5. So the -1 and the -2, the negatives cancel out, and then 2 times 1 is 2, and 2 times 5 is 10. So our y-intercept is at 0, 10. So now if my zeros are between 1 and -5, Fozzie, this is the best part. All right, but maybe I should give it my full attention because this is one of the key things you can do once you know your zeros, and this is what I was referring back to on the first one. If 1, 0 is 1 and 1 is -5, well, right in between that should be my axis of symmetry, which is also where my vertex is. So if I'm at 1 and -5, and then let's go to 0, -4, -1, -3, -2. It's right in the middle, our axis of symmetry. So our axis of symmetry should be where our vertex is too, right? So we can find our vertex because x, we know for sure, is going to be -2. And we can plug in -2. So we plug in -2, we get -2 minus 1, which is -3, -2 plus 5, which is 3, and we multiply that out, the negatives cancel out, and we get 2 times 3 times 3, or 3 times 3 times 2. Either way, you should get 18. So our vertex is -2 and 18. So now we actually have enough information to graph it, Fozzie. I mean, instead of making a table, I think this is a pretty nice alternative, right? So let's look at what that would look like. So I went ahead and I did the graph for you. We have our key features, of course, just like we had on the last one. So our zeros, if you look on this graph, are at 1 and -5. Our y-intercept, you can put a dot or at 0, 10. Axis of symmetry at -2, and the main vertex at -2, 18. So knowing all that, you can make a rough parabola or quadratic graph, which looks just like what we have right here. Hopefully you see how we did that. If not, again, please visit the teachers around you. Please feel free to message me, star it for when I get back. I know I gave a lot of attention to my dog during that one, but hopefully you understand how we are able to do that. All right, moving on. Graph the following function, h of x equals x squared plus 7x plus 6. Using the coordinate grid below, identify the key features of the graph, including the x-intercept, y-intercept, axis of symmetry, and vertex. All right, so here's where things get a little more spicy, so to speak. Well, actually, I don't think we need to convert this one. Sorry, we can keep it exactly how it is and still solve most of this. I can definitely tell what the y-intercept is because, again, our y-intercept is when x is 0. So if x was 0, then our y-intercept would just be 6, 0, 6, because these would become 0, and then you're left with 6. All right, so now let's look at what our zeros or our x-intercepts would be. So you could solve this 2 different ways. You could do the quadratic formula, or this one is actually really easy to do the x method. So we're going to put 6 on top, 7 on the bottom, and then if you can think of what it is, you should have got 1 and 6. 1 and 6. So we can just change this formula to be x plus 1 and x plus 6. Now we can do a lot with this. Again, you could find your x-intercept by plugging in 0, or your y-intercept by plugging in 0 for x. You can find your x-intercepts because if either of these become 0, then the whole thing would be 0. So -1, if you plugged in -1, -1 plus 1 is 0, or -6 plus 6 is 0. So our x-intercepts, or our zeros, or our solutions are -1 and -6. All right, now that we know that, -1 and -6, well, either way our graph is, it's actually going up like this time. We can find our zeros because we have -6, -1, so -5, -2, -3, -3. So -3 is right, -3.5 should be right in the middle. 1, 6, 5, 2, 4, 3, 3.5. Okay, so not a fun number to plug in, but we're going to plug that in to find our vertex. And we get that our vertex is about 8.75. So Now we have all of our key features. So you can go ahead and graph these different items, and you get something that looks like this. So your y-intercept is at 6, your x-intercepts are at -1 and -6. Your axis of symmetry is about at 3.5. Let me show you these features. So 6 and -1, these are our zeros, our y-intercept. Our axis of symmetry is, maybe it's more like right around here, because this would be about 3. So axis of symmetry. And then lastly, our vertex is around -3 and -8.75. Hopefully you see how I was able to do that. All right, let's move on to the next one. All right, we're going to write a short real-world story about this graph. You can do a lot of things. So let's look at it. We start off just a little bit below 30, and then it goes up into the air and reaches max height around 2.5, and then it comes down and hits the ground right before 6. So a rocket, a ball, or a dog is thrown, launched in the air from an initial height of 29 feet. The rocket, ball, or dog reaches a maximum height of about 60 feet at about 2.5 seconds, or minutes, or hours. The rocket, ball, or dog lands, crashes on the ground in almost 6 seconds, or minutes, or hours. You can change this to a lot of different things. I just thought those would be funny. Not that a dog being thrown is funny, but just thought that would throw you off and wake you up. Should I throw you? Want to be thrown? No? Okay. I don't think he liked that. All right. Hopefully that visualization helped, right, Fozzie? Okay, let's move on to the next one. In a physics lab, I don't think this one's throwing dogs. He's over here now. An artifact is dropped from the roof. Is the artifact a dog? The school building. The school building, 98 feet above the ground. The height, h, in feet of the ball above the ground is given by this function, -16t plus 98, where t is the time in seconds. I know. Is it because I said ball? It is because I said ball. Oops. I'm sorry, Fozzie. We're not playing fetch right now. Oh, I said fetch too. Okay, well, are you looking at the camera? Okay, how about you help me with this problem? So, our y-intercept is 98, because again, if we plug in 0 for t, all that's left is 98. So our intercept is clearly 98. All right, so now this is an easy way to find our zeros. And you can easily do it with one of these that doesn't have a t by itself. Basically, we're going to move 98 to the other side, Fozzie. We're going to set this equal to 0, because remember, if y is 0, then that's where our x's would be, or x-intercepts would be. So to move the 98 to the other side, we're going to subtract 98 on both sides. And the 98 over here cancels out, and you get -98 on the other side. So now we're going to get rid of the 16. So we're going to divide negative 16 on both sides. The negatives are going to go away, and you get about 6.25. I know, it's sad that it's not a perfect number. I agree. So what are we going to do? T squared equals 6.25. So how do we get just t? What does just t equal? That's right, we're going to take the square root. So square root of 6.25, we get it's either going to be positive 2.5 or negative 2.5. So positive 2.5 or negative 2.5. Okay, sorry, Fozzie. I love you, but gotta focus on this. Okay, so hopefully you see how I got that. And so now we know our y-intercept and our x-intercepts. And again, so positive 2.5 and negative 2.5, right in the middle is 0. It's 0. He's being cute again. So our max height or our intercept is going to be our y-intercept. So the 98 that our y-intercept is actually the same as our vertex or our axis of symmetry. So our vertex is 0, 98, and let's see what that would look like. Looks something like this. It was hard to get this on a graph that looks great, but our zeros are negative 2.5 and positive 2.5, and then it goes all the way up to 98. And then the graph, the points go downwards. I'm going to eventually start talking about this more, but if it has a negative in the front, you see how it's negative 16t squared? That's how you know that the points are going to go down, and then you're going to have a max height. Whereas if it's positive, you know the points are going to go up, and you're going to have a minimum height. So you're going to see that more often as we go through these next couple pages. All right, Fozzie? You're so cute. All right. So now we're looking at how far the artifact has fallen from time 0 to time equals 1. So, or t equals 1. We're just going to plug them into the equation. We already know what it would be at 0. It would be 98. So let's see what it would be at 1. So 1 squared, negative 16. Negative 16 plus 98, we get 82. So it went from 82 to 98, or it changed, it had a 16-foot change, because 98 from 82, 16-foot change. So the answer for part B is a 16-foot change, or went from 98 to 82. You can put either or. All right, so now for part C. So now we're going to look at how much it changes from when time is 1 to time is 2 compared to time is 0 to time is 1. So again, if you plug in 1, you get 82. You just saw that in the previous one. If you plug in 2, 2 squared is 4. Then you have to do 4 times 16, and then 98 minus 4 times 16. You get 34. Wait, I put h is 3, but I'm very positive that it's h is 2. Same over here, I put h is 1, but it's h is 2, is 34. So 82 to 34 is a much bigger change. It's a 48-foot change compared to the 16-foot change from time equals 0 to time equals 1. So it's a bigger change, you could put. All right, this one looks like a lot, but it's not as bad as it looks. So Mobistar is a mobile service company that sells 800 phones each week when it charges $80 per phone. It sells 40 more phones per week for each $2 decrease in price. The company's revenue is the product So remember, product means multiplication. Sorry, random side tangent, but product means multiplication. It's going to be important in a second. Of the number of phones sold and the price of each phone, what price should the company charge to maximize its revenue? Let D represent the number of $2 decreases in price and let R be the company's revenue. Write a quadratic function that represents the company's revenue. Okay, it gives us a hint, but let's talk that over. A lot of mumbo jumbo, but they sell 800 phones each week and then $80 per phone, and then it sells 40 more per week, so that goes back to the week, the 800, and then a $2 decrease in price, which goes to the $80 price per phone. And they want to know the product of that, so they want you to multiply both of them. So your hint is the number of phones sold will be 800 plus 40 D, since they sell 40 more phones for every $2 decrease, the price for the phones will be 80 minus 2D, sorry, not dollars, but is the number of decreases for each decrease is $2. Okay, a lot of mumbo, a lot of jumbo, but basically you have 800 plus 40D and 80 minus 2D, and we're going to get the product. We're going to multiply them. And this is going to be our quadratic formula. So you're going to slowly do this. You're going to break it down. 800 times 80, then 800 times negative 2D, 40D times 80, and 40 times negative 2D. Hopefully you vaguely remember doing that. And then you get 64,000 minus 1,600D plus 3,200D minus 80D squared. Because remember, D times D is D squared. So now we just need to combine like terms right here. And then we get our formula. And I put it in the correct order. We get negative 80D squared plus 1,600D plus 64,000. All right, so in part B, we're going to find the vertex of the quadratic function. And how will finding the vertex help you determine what price the company should charge to maximize its revenue? Well, it kind of says it right there that the vertex is going to be the max. It's going to be the height of the profit. So we can find our vertex because our vertex, since it should be split perfectly for our zeros anyway. If we do negative 1,600 divided by 2 times negative 80, this will be what our x should be when we have our vertex. So let's start with negative 80 times 2. We get negative 1,600. 1,600 divided by negative 160, we get 10. Yep. So now we're going to plug 10 into the equation. So 10 squared is 100, negative 80 times 100 is negative 8,000. 1,600 times 10 is 16,000. So then you combine these and you get 80,000 plus negative 8,000, and you get that when R is 10, then Y is 72,000. So that is our max revenue. So the company would make the most amount of profit at $72,000 if there are 10 $2 decreases. All right, everyone. So the last step is to graph this function. It you can do it with a lot of the information we have. This one's a bit tricky, so just take my word for it that it's going to look something like this. Again, you'll see the max height is 72,000. We know our y-intercept. We know our axis of symmetry is at 10. We know from way early on, we can figure out what our zeros would be, and we get something that looks like this. Yep. All right, that concludes section 4. So let me know if you have any questions. Feel free to message me. Feel free to go to another teacher and see what they have to say. This one had a few tricky moments here and there. So I can definitely go over some stuff when we get back, but I hope you feel confident and comfortable, and I'll see you in the next section.